in this case, again, guys, we're looking into evaluating. All right. Now, we have two angles. Now, it's not very explicit what our angles represent. And when we have our phones away, then we can recognize that we have some expressions that from last chapter we recognize, right, in evaluating. So we have sine of u equals 4 over 5. Remember, going back to the old, like we recognize that not from the unit circle, right? But we recognize that from, because the hypotenuse would not be 1 here, right? So it's not a point on the unit circle. But we recognize that as like an opposite over hypotenuse. So kind of going back to the good old days, opposite over hypotenuse. And then we have a restriction, which was another unit we talked about. Cosine of u is negative. Now, hopefully, we've done that so many times. You're like, oh, that means the triangle has to be in the second or the third quadrant, right? So let's go ahead and draw this triangle, u. So remember, we have to create a angle that says a central angle, perpendicular, right? Remember that? Here's u. So we have opposite over hypotenuse. Hopefully, you guys recognize by the Pythagorean theorem, this is a Pythagorean triple. So that would be a 3. Since it's in the second quadrant, that's a negative. Says yes? No? Why is it 3? Because that's a Pythagorean triple. If you do the Pythagorean theorem, you would get 3. But we'd recognize the 3, 4, 5 triangle is a very special and common right triangle that shows up a lot. So the next one is 5 and 6. So we have v is our angle, and v is positive, 5 and 6, but tangent is positive. So we got to think, well, when is tangent positive? Tangent is positive in the first and the fourth quadrants. But if we created my triangle in the fourth quadrant, would the opposite side be positive? No, right? Because the triangle would have to look like this, right? So that'd have to be a negative 5. And we wouldn't have positive 5 or 6 if we wrote it like that. So our triangle has to be over here. So here's v. Here's 5. Here's 6. Is it OK if I do the Pythagorean theorem in my head? 6 squared is 36. 5 squared is 25. 36 minus 25 would be 11. Square root of 11, 9. 36 minus 25 would be 11. Square root of 11, right? Am I good? Or do I show my work? OK. All right. And again, should that be positive or negative? Well, obviously, it's in the first quadrant, so it should be positive. We like things in the first quadrant. All right. So there's our u and our v. So now it's asking us to find the tangent of u plus v. So we just got to do the formula. And again, I cannot highlight this enough, guys, with my mistakes and your mistakes. Just rewrite the whole problem as it is. OK? Make sure you guys have the formula. Tangent of u plus tangent of v all over 1 minus tangent of u tangent of v. Until you get used to this, right, just practice rewriting the whole formula. Practice plugging things in. So what is the tangent of u? So we go over to u. Tangent of u is 4 over negative 3. Plus tangent of v. That is going to be 5 over the square root of 11. All over 1 minus tangent of u. Tangent of u, which is, wait. Is that right then? Yeah, tangent of u, which is negative 4 over negative 3. Or let's just write this as a negative 4/3. And then times the tangent of v, which is 5 over square root of 11. OK. Now, some of you might say, well, I don't want to do like all of that work and all that kind of stuff, right? So like that, at least good from there. Now, again, if we were going to come up to this problem, again, guys, think complex fractions. We have fractions within fractions, right? So if we can find the common denominator of our fractions within our fractions, we can get rid of all that stuff, right? So what's the common denominator here? 3 times root 11. So let's go and multiply everything times that. And when we do that, we get a negative 4 through 11. And this would be plus 15 all over 3 root 11. And then, sorry, these would both divide out. So this would be a negative 4 times 5, which is a negative 20. And then times there would be a plus 20. OK? Yes? What? OK. Now, obviously, we could rationalize the denominator, but you guys can see then we're going to start dealing with some bigger numbers and stuff like that. So as long as you guys at least understand how to use the two triangles, and I think we get to this point, we'll be fair enough from there. OK? Obviously, you would be expected to do a rationalizing. Depends on the question.